All right, last few questions on this review sheet. Question number 15. The radius of a sector, so a sector is like a piece of pizza. The radius of a sector is 10 millimeters. The measure of its arc is 120. What is the arc length and area of the sector? So area is x over 360 times pi r squared. Arc length, x over 360 times 2 pi r. 120 over 360 times pi 10 squared. 1/3 of 100 pi, or 100 thirds pi. Arc length is going to be 120 over 360 times 2 times pi times 10, or 1/3 of 20 pi, which is 20 thirds pi. Arc length and area of a sector. A chord at a distance of 6 centimeters diameter is 24. Forms a segment, a shaded region with its minor arc. What's the area of the segment? We never use this terminology, so I will not use this terminology on the final. But this is what the picture would look like. So the big picture is area of the sector minus the area of the triangle, because this 6 is the distance and that's a right angle there. That would be the big picture. So we need to, first of all, figure out what the measure of the arc and or the measure of the central angle is going to be. And I'm going to do that with trig. So in order to find the area of the sector, I need to first of all find x here. So let's see, I have adjacent and hypotenuse, so cosine of x is equal to 6 over 12. Cosine of x is equal to 1/2 or 0.5. If you're in pre-calculus, you'll have to do this with an exact value. Since we are not, I'm going to go ahead and let you approximate. So x is going to be 60 degrees. That's 60 degrees. So the whole thing is 120. That's very fortunate. So 120 over 360 times pi r squared. That's 1/3, just like the last problem, of 144 pi. And 144 divided by 3 is 48. Okay, the triangle, I have 1/2 base times height. So I can find this entire base, realizing that if I use, I'm just going to call this small part here y. If I use Pythagorean's theorem, I'm going to be able to quickly solve for it. Or you might realize that if 12 is the hypotenuse and one of the legs is 6, it has to be, well, wait a second, 30, 60, 90. Or we already knew that was a 30, 60, 90. Oh, piece of cake. So if this segment is segment AB, 12 radical 3. So the area of the triangle is 1/2 base times height, or 36 radical 3. So my final answer, the area of the shaded region, is the area of the sector minus the area of the triangle. That's the exact value. I will not use this terminology on the test. I'll probably just draw the picture and throw a shaded region in there for you. Number 17, a square is inscribed in a circle of radius 12 millimeters. What's the area of the square? I'm going to inscribe a square. I'm going to try to inscribe a square. Do the bestest I can. All right, so the center of the square is the same as the center of the circle. So both have radius 12. And several ways to do this. The quickest way might be to realize that, well, this is going to be a diameter. And then likewise, you have a diameter going that way. And a square is a rhombus. 1/2 diagonal 1, diagonal 2. 1/2 24 times 24. Half of 5, 76. 288 square millimeters. Treat it like a rhombus. In triangle PQR, P is 43 degrees, PR is 15, PQ is 18. 1/2 base times height to find the area. And these directions are nice. They kind of lead me to it. I'm going to actually flip this around first. I'm going to find the altitude to PR. I could have done this either way, but I drew it this way. So I'm going to change this to PR. The process will be the same. Sorry about that. So I'm going to find the altitude to PR. I'm going to call this blue segment the height. So this is going to be sine of 43 degrees is equal to opposite over hypotenuse. Opposite over hypotenuse. The sine of 43 degrees, the sine of 43 is 0.6819. Multiply both sides by 18. Area is equal to 1/2 base times height. 1/2 15 times 12.28 is equal to 92.1, no units. Remember though, the question really asked us to find the height to PQ, so I would find this. The process is the same. Here's my altitude. Here's my angle. I would use opposite over 15. Sine of 43 equals opposite over hypotenuse. Number 19, the area of the base of a pyramid is 90 centimeters squared. The altitude of the pyramid is 14. A cross section, we did not deal with cross section at all, so you can throw out 19. No need to worry. Poof, it's gone. All right. We have an isosceles triangular prism. The triangle has sides 5, 5, and 8. The altitude of the prism is 12. Volume is big BH for a prism. Area of the base, height of the prism. This is a triangle, 1/2 base times height. I need to find the height in an isosceles triangle. That splits the 8 into 4 and 4. The height would then be 3 using our Pythagorean triples, 3, 4, 5. So big B is going to be 1/2 of 8 times 3, and that's 12. So volume is going to be 12 times 12, which is 144 cubic centimeters. Okay, in order to find total surface area, I really need also to find lateral surface area so that I can use the formula TSA equals LSA plus 2B. I guess I should have finished. Yeah, I'm okay there. So if B is 12, that's going to be 12. LSA is perimeter times height. The perimeter is 5 plus 5 plus 8. So the LSA is 216. Plus 24, 240 square centimeters. All right, good luck. See you tomorrow.